So this is lesson 1.6 in elementary algebra, and the name of this section is factoring. And factors, what are they? Well, if we have the numbers 3 times 4 equals 12, 3 and 4 are factors of 12. That means that the 3 goes into 12 evenly and the 4 goes into 12 evenly. 6 and 2 are also factors of 12 because both of those numbers go into 12 evenly, as well as 12 and 1 equals 12. Okay, so those are factors. Numbers that divide into the bigger number that we're looking at evenly. So the factors of 12 are 3 and 4, 6 and 2 here, and 12 and 1 there. All right, so another bit of vocabulary that you're going to be reminding yourself of is a prime number. A prime number is any positive integer, okay, so it has to be positive, larger than 1, whose only positive factors are itself and 1. So for example, 6, what are the prime numbers of 6? Well, 6 and 1, but also 3 and 2. This is not a prime number. 7. Are there any factors of 7 besides 7 and 1? No. When it's just the number itself and 1 are their only factors, then that is a prime number. So just to give you an idea of some prime numbers, 3, 5, 7, 11, 13, 17, 19, 23, and 29. And you just keep going on with those numbers where there's no factors other than the number itself and 1. Okay? Now, the reason I told you that is because we're going to be looking at prime numbers, and we're also going to be looking at factors. Now, it might have been a long time ago, but at one point you learned a factor tree. So if you have a number there, and you are looking for what are called the prime factors, what that means is we're looking for all of the factors, or all the numbers that go into 60 evenly, but are prime numbers. So this is what we do. We make a little upside down V there, or a teepee, or a mountain, or whatever you want to call it, and just find two numbers multiplied together that give us 60. So those two. And if those numbers that we come up with are not prime, we do another one. Any number that's even is not prime. So what goes into 10? 5 and 2. Are 5 and 2 prime? 5 is prime, 2 is prime. Nothing goes into either one of those. So I like to circle those. All right, 6. What goes into 6? 3 and 2. Are those prime? Nothing goes into 3. Nothing goes into 2. These are the prime factors. And what we do is we write them from smallest to largest with a multiplication sign between each one of them. So those are the prime factors of 60. And before we stop there, if we multiply a number by itself like that, we write it as 2 squared times 3 times 5. It's just a more concise way of writing it. And that's the answer. That's what they're looking for, the prime factors of 60. All right, let's keep going. They want us to do in this next one the prime factors of 630. Well, since 630 is an even number, I know that 315 and 2 are two numbers that multiply into that, or divide into that. 2 is a prime, so I circle it, so I'm done there. But 315, it ends in 5, so I know that 5 goes into it. I don't know how many times off the top of my head, but 63 times. So 5 and 63. I know that 5 is a prime number, but I also know that 63 is not, because I know 9 goes into it 7 times. Okay, and I also know 7 is a prime number, but 9 is not, because 3 times 3 is 9. Circle those because those are prime. So the only thing I care about is the 2, the 3, the 5, and the 7. And again, that's listed twice, so I will write it like that. Now, if I multiply all those numbers together, I will get my 630 back. So all I did was found the numbers that when I multiply all of them together, I get what I started with. So the reason that we did the product of primes, or listed the prime factors, is so that we could better reduce fractions. So if you look at example 3, we have 210 over 231. So what we're going to do is we're going to take the 210 and we are going to use the factor tree, and we are going to use, I know that 7 and 30 go into 210 because 7 times 3 is 21, so 7 times 30 must be 210. I know that 7 is prime, so I circle it, and I just look at my 30. I circle my 3, circle those. Okay, so my numerator for 210 is 2 times 3 times 5 times 7. Okay, now we're going to look at 231 and do the factor tree. And let's see, 3 goes into 231, I don't know how many times. 77. Alright, 3 is prime, so I'm going to circle it. 77 is 11 and 7, and both of those are prime. Okay, so once we do that, we can cancel. The same number on top and the same number on bottom we can cancel, only because there's multiplication signs between them. If there weren't multiplication signs between them, I couldn't. So that means whatever I can't cancel, I multiply. And this just has an 11. So what I just did is I took 210 over 231 and reduced it to its simplest term, or its simplest form, or the smallest fraction. Okay? That's why learning how to find the prime factors of a number is so important. It's not a real easy way, or not a real simple and quick way to reduce, but it is a way to reduce fractions, and that's the whole purpose there, is it gave us a chance to reduce. And it's used later on in other things too. Alright, so example 4 says take 3/4, and instead of writing it as 3/4, write it as 3/4, but use different numbers. So how did we go from 4 to 20? Well, we multiplied by 5 to get 20. And if we multiply that by 5, then we multiply the top by 5. So 3/4 is the same as 15/20. And that's what they were doing in example 4. Alright, next part of this is reciprocals and multiplication with fractions. So let's just go ahead and start out with some multiplication. In example 5, it says multiply 3/4 times 5/7. Now if you remember multiplying fractions, you multiply the top numbers, multiply the bottom numbers, okay, and you're done, because this can't be reduced. Alright, if you look at example 6, it says multiply 7 times 1/3. Whenever you have a fraction times a whole number, you make the whole number into a fraction by just putting it over 1. And then you multiply the top number over the bottom number, and you're done. Now when you have something like 2/3 and you have parentheses and it says cubed, what is being cubed here? Well, everything in the parentheses is being cubed. So 2 is being cubed and 3 is being cubed. So 2 cubed, 2 times 2 times 2 over 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Okay, let's keep cruising along here with example number 8. It says we've got negative 3/4 times 5/7. One negative there, so we have an odd number of negatives, so our answer is going to be negative. Multiply the top, multiply the bottom. Okay, not too bad. The next one is negative 6 times 1/2. And remember, if you have a whole number, just put it over 1 and it makes it a fraction, and then we can multiply negative 6 times 1 and 1 times 2, and then we can reduce that. 6 over 2 is 3, and because there's only one negative, our answer is negative. Alright, last one here, negative 2/3 times negative 3/2. Two negatives give me a positive. 2 times 3 is 6. On the bottom, 3 times 2 is 6. 6 over 6 is the same as 1. Alright, two numbers whose product is 1 are called reciprocals. So, for example, if I have the number 5, and I want to multiply it by something and get 1, what do I multiply it by? I multiply it by 1/5, because 5 over 1 times 1/5 is 5 over 5, and any number over itself is 1. Okay, that's what a reciprocal is. Negative 2. The reciprocal of that is negative 1/2, because we put that over 1. Negative 2 times negative 1 is positive 1. Positive 2. What am I thinking? 1 times 2 is 2. Any number over itself is 1. Okay, so you have to get positive 1. You can't get negative 1. What if I have 1/3? Basically, I just flip it upside down is all I'm doing. Okay, so when I had 5 and I wanted to find the reciprocal, I just take 5 over 1, turn it upside down, and that's the reciprocal. So they're reciprocals of each other. And these will be important as we get going with these. Things will start making sense while you're learning all of this stuff, which brings us to some division with fractions here. And we'll save that for the next video.